Waves. When we hear the word, we often think of ocean waves. Waves created by winds transferring energy through the water. But there are invisible waves all around us. Every day we experience sound waves and light waves. Even though we can't actually see these waves moving through the air, these waves transfer energy from one place to another. Like when we talk, we are producing sound waves. The vocal cords in our throats are producing energy vibrations that move through the air and can be heard by others. Instruments like drums and guitars also produce sound waves when we use our energy to play them. And have you ever seen solar panels? They absorb the energy that comes from the sun in the form of light waves. The light waves from the sun can also hit our body. Even though we can't see these ultraviolet light waves, they are transferring energy from the sun to our bodies. You can see evidence of this when someone gets a sunburn. In this video lesson, we will learn about the invisible waves that are all around us. And remember that you can download all the fun extension activities that go with this lesson by using the link in the description. So let's get started. Waves transfer energy. Sound is actually just vibrational energy that hits our eardrums, but every sound wave is unique depending on what kind of sound it is and how loud it is. To show you, let's take a closer look at the different parts of a wave. Here's our first sound wave. The top of the wave is called a crest, and the bottom of the wave is called a trough. The vertical distance between the middle of the wave and the top or bottom of the wave is called the amplitude, and the horizontal distance between the tops or bottoms of the waves is called the wavelength. When a wave has long wavelengths, it means that it has a low frequency. If a wave has short wavelengths, it has a higher frequency. We might say this wave has a deep sound because it has large wavelengths, and if we shorten the wavelengths, we get a higher pitched sound. So sound waves with shorter wavelengths have a higher frequency. But if wavelength determines the pitch of the sound, what determines how loud the sound is, also known as the volume? Well, that's where amplitude comes in. If we increase the amplitude, we get a louder sound. And if we decrease the amplitude, we get a more quiet sound. Now that we know about amplitude and wavelength, let's listen to a few sounds and try to determine what their sound wave looks like based on how they sound. First up, a lion's roar. This sound is very loud, so it has a high amplitude. And it has a pretty deep sound, so it has a long wavelength, also known as a low frequency. Next up, an annoying mosquito flying around nearby. It is a very high-pitched sound, so it has a very short wavelength, also known as a high frequency, and it is pretty quiet, so it has a shorter amplitude. Finally, let's listen to this electric guitar. It has a high frequency, which means it has smaller wavelengths. And it's very loud, so the amplitude is very tall. Now that you know all about the amplitude and wavelength of waves, you're ready to put your skills to the test with the printable activities linked in the description. To play around with your own sound wave simulation, you can visit our friends over at Java Lab Science Simulations. The link to the simulator will also be provided in the description. Thanks for joining me today. I'll see you next time.